thank you for coming. I'm gonna get started. I'm gonna talk to you today about deploying a Micronaut application which persists with MicroStream to AWS. This is a talk that I wanted to do for a long time because typically we don't do talks in production about how to take a technology and put it in production, and kind of obsessed of simplifying putting things in production. And they gave me the opportunity to do this talk with you today, and thank you for coming in the first slots in the morning. My name is Sergio del Amo. My contact is in our website with my name, sergiodelamo.com. I work for the Micronaut Foundation, which is a foundation structure around developing and advocating for the framework. So thanks to the foundation, I'm able to be here with you today. The foundation have several partners. Object Computing, which is our ambassador partner, MicroStream, which is a silver sponsor of the foundation. We have the people from -Q that they do a great NQT work, the people from Safri.net, which is actually a German company, and Visor Games, who is a game studio company. And thank you also for our partners, to the Gradle, to JetBrains, and special thanks to Oracle, which is an engineering partner of the foundation. Micronaut is, for those of you who don't know about Micronaut is a JVM framework. It's an open source JVM framework. You can write applications with Java, with Kotlin, with Groovy, and you can use many persistent solutions with Micronaut. Probably the most well-known is Micronaut Data, which comes in many flavors. Has the repository pattern that we all love, like you write an interface, and Micronaut Data will actually, the difference is that Micronaut Data will build the implementation at build time, and it comes, as I said, in many flavors. You have a JDBC implementation, you have a JPA implementation, we have a MongoDB. If you are looking for something reactive, we have R2DBC, support for Hibernate Reactive as well, and as you see, we have also integrations with things such as Redis, Juke, Neo4j. And the one I'm going to talk to you today is Eclipse Store or MicroStream. I have changed my slides to reflect the new name that MicroStream is going to adopt. So if you were going to use the integration today, you are still going to be using MicroStream. Micronaut 3 ships with a module called MicroStream, which integrates with MicroStream 7. Micronaut 4, which we are going to release GA in the next 2 weeks. We are currently shipping already milestones, and the demo that I'm going to do with you today is using Micronaut 4. It uses MicroStream 8. So why Eclipse Store? One of the things that when you use Micronaut, I am trying to always say is startup time is not only important for production, which of course it is important, but it's also important for development. At the end of the day, most of the money companies spend is in developer salaries, and when you have an application that starts fast, you typically write more tests, you write more functional tests, because writing a functional test means starting the application. What you will see with Micronaut is that you typically, instead of doing the testing pyramid that we are all used to seeing in slides in conference, where a lot of unit tests in the bottom, you will see that typically you will do the other way around, where most of your tests are functional tests. Those are the tests that allow you to sleep well at night. And the integration with Eclipse Store, what gives you is even an extra boost in startup time in test and things like that, because since you are not saving to a database, you don't have to use Docker, for example, to start with test container a database for you. So you're going to see that writing tests and starting your application in local development is blazing fast, because essentially you are not waiting for anything to start. You are not waiting for a database to start. You are not waiting you don't have to run Docker Compose. It's really simple and really fast to develop and to test. What you're going to see is with Eclipse Store as well, you're going to get a simple architecture. And today, the architecture that I'm going to show you, you're not going to have any Kubernetes, you're not going to have any complicated architecture. It's going to be like a travel back to the 90s for those old enough as me, and you will see like the joy of having an application architecture that you can comprehend and put in your head. Is Clipstore in combination with Micronaut is especially suited for read-heavy applications. So one of the beauties of the Clipstore model, where you have basically the data in memory, is that traversing a graph using the JavaStream API is blazing fast. So if your application is read-heavy, this is especially suited for this kind of applications. Also is cloud optimization. So I always say that the cloud vendor build typically goes, I always joke like in AWS and in other clouds, typically the compute is cheap, but where they get you is in the load balancers and in the databases. And one of the things that you're gonna get rid of with this architecture is a database. So you're not gonna have to have a database or a database with replication. I'm gonna show you several alternatives that we support. And I will tell you what I think of each of them. But essentially, such an architecture is going to save you money. I'm going to be using the AWS symbols for describing the services. So I'm going to, before introducing the symbol, I'm going to try to have a slide where I basically say what the symbol refers to. So the first thing that we are going to use is EC2. EC2 is probably, it's not the oldest, but it's one of the oldest services for AWS, and it's essentially compute that you can turn on or turn off on demand, and it comes with different kind of machines depending on your needs. So we are gonna, for example, I'm gonna show you today a demo with an extremely small EC2 machine, but you can scale it up. And they also have a different architecture, different kind of machine depending on the kind of application that you have. I'm gonna show you today like the T3 family of EC2, which is like the general type, and we're gonna see that you have different configurations that can go up, and there are even machines with bigger memory capacity. So one of the things when you have to work about Clipstore is especially suited for vertically scaling. What that means is that typically when you have an application that loads in the data that your application handles and also in the traffic that you get, the way that you manage to handle that traffic is by creating, by basically having a bigger machine. A machine with more resources, a machine with more CPU, a machine with more memory. And that's what we typically say as vertical scaling. Nowadays, we are used to scale mostly horizontally. The typical architecture nowadays is you will put a load balancer, and then you will have multiple instances of EC2 or other compute resource in other clouds, and the load balancer will distribute the load between the different machines. When you are using a Clipstore, and you, especially in the VM that is going to persist to disk or to a different storage target, you will see the path is to scale vertically instead. And this is a quote from the MicroStream documentation, the next to be a Clipstore documentation. It tells you at any time only one JVM process must directly access the file representing a unique set of data. So that typically means vertical scaling to me. And their solution for horizontal scaling is in the next paragraph. They tell you like the requirement to distribute an application over multiple processes must be solved by a clustering approach. And they do have a clustering solution, which is the MicroStream cluster. So today I'm going to show you the vertical scaling solution, which I think it will fit many applications. Some applications may need to go to the clustering solution, but what I see and what I see also from talking to the people from Clipstore is that we often underestimate how much volume of data and traffic we can handle with a beefy machine when we are using a solution that reads blazingly fast. And this is, for example, a table of the different memory options that you have in the simplest of machines from EC2. I think I have T3 micro in my demo, which is half a gig, and it can go up to 32 gigs in the simplest configuration. You can even have a much bigger machine in EC2. So this is the architecture of MicroStream application. Typically, you will have your Micronaut application there on the top. You will load your data in memory, and when you have to persist, Clipstore will basically save that to the storage layer. So, and here comes EBS. EBS is Elastic Block Store. I think I heard once a definition like this is like a hard drive in the cloud. And the idea is that you can take an EC2 machine and attach a hard drive, and you can basically format the hard drive and mount it to the EC2 machine. So the ideal architecture, I think, this is not the architecture that I'm going to show you, but I think this is the best architecture for a Micronaut Clipstore AWS deployment, which is you deploy your application to EC2 and you mount Elastic Block Store to the EC2 machine, and you essentially write to disk in that Elastic Block Store. Why not writing directly in the EC2 machine? You could do that, but I like to treat the EC2 machines as basically a machine that you can easily discard and replace by a bigger one. So you can start with an EC2 machine with low memory requirements, and when you see that your application is growing in both traffic and the amount of data that you are handling, you can grow your EC2, you can basically change your EC2 machine by a newer one with more memory and still keep the same EBS volume where you are saving data to. Another alternative that we have is to use Amazon EC3. Amazon EC3 is this, all the clouds have this kind of solution. It's called typically like blob storage, they typically refer to. Amazon EC3 is the Amazon solution. They have a lot of options here for EC3. They have encryption, replication, versioning. You can use Amazon EC3 to host like a static website, and you can use Amazon EC3 as a storage target for Clipstore. So Clipstore supports a storage target. So apart from saving to disk, you can say instead of saving to disk, save to S3. We support that, and this is the architecture that I'm gonna actually show you in the demo, where I will be saving to S3. That it has a disadvantage, in my opinion, instead of using EBS, is that even saving to S3 is going to be fast. You're going to have to do a network request because you're going to communicate to S3 via an HTTP request, and that's going to be always a little bit slower than saving directly to disk. So how does it work in Micronaut to use S3 as a storage target of a Clipstore application? This is only supported in Micronaut 4, and this is only supported in MicroStream Micronaut 4. Essentially, you have to add these dependencies. They have like, you have to add we have one dependency called Micronaut AWS SDK version 2. Then you will have to add the dependency from Amazon to S3 directly. What we will give you with those two dependencies, you will add those dependencies in your project. For example, if you are working with S3, even if you were not using MicroStream, we will essentially register the S3 client class, which is the class from the AWS SDK, as a bin in the application context, so that you can inject it in any other bin. And we leverage that out of the box, so that we will use the different configuration options. So if you deploy this, as I am doing, to an EC2 machine which has like an IAM role with permissions to save to S3, it will work out of the box. It will discover that it has the IAM role, and it will configure itself. The other dependency that you need is the MicroStream AWS S3, I set all these dependencies as runtime only. I am not using them in my code at all. They are only used to persist in production, right? And the other two things that you need is then on the top in the application production properties. So Micronaut supports the concept of environments. And the architecture that I'm going to show you today, the idea is to have multiple environments, is to have a dev environment when I am developing in my local machine, a test environment when I am testing, and a production environment when I go to production. And you can have like an application dash, whatever the environment is, .properties or .yaml if you were using YAML configuration, and that will be picked only when you were like running the application in production. So you have to do two things. One is you see is MicroStream.s3, and then the bin name. So it could be default, could be that's whatever the name you prefer. And then you have to specify the root class. So that's where the graph is going to be. And then you select the bucket. That's where you're going to save. So that will be the bucket name. I created this bucket already. So this bucket exists. I actually don't know if it will try to create the bucket if it doesn't exist. I have not tried that. Another alternative that they support as a storage targets in MicroStream that we support as well is Amazon DynamoDB. So Amazon DynamoDB is a database, a non-SQL database. Typically is like a key value database where you will have typically either a hash key and a sort key, or only like a hash key, and you can use it as a storage target. Amazon DynamoDB you can pay also on demand, so you could configure it so that you don't have like reserve concurrency, and if you have really like you are starting, this is gonna be really like a cheap way of testing this, and the architecture will be exactly the same. You will have your application, your Micronaut application deployed to EC2, and when you go to persist, you will use the storage target to persist to a DynamoDB table. Here I actually have tried. If you don't have the DynamoDB table, so in DynamoDB the database is typically, when you talk about a database, a table. So the DynamoDB table will be created for you if it doesn't exist. Configuration, not surprises, it's really similar to the other one. You're going to have the same structure. You're going to have to add the MicroStream, now DynamoDB, and then you have to add the DynamoDB dependency, of course, instead of the S3. They're, again, all runtime only. We don't use them in our production code, only to save in combination with MicroStream. And then the other important thing is we have to specify the name of the table of DynamoDB to save. That's there, up there in the application production properties. So you specify both the root class and the table name where you want to save. So really easy, nothing complicated. This is another storage target, which I don't really understand the appeal, but they exist, which is to save. I guess if you already have like a database that you are using for something else, you can configure a relational database such as PostgreSQL to save to a table of PostgreSQL the data from MicroStream, and you can configure it as a storage target as well. And the way it will work in Micronaut is you will have runtime only dependencies. When you work with a database in Micronaut, you will typically have a connection pool dependencies. In this example, I have the high-carry connection pool there at the bottom. You will have the database driver dependency. So I have here PostgreSQL, and I have also the MicroStream AFS SQL, which you will need to save in this case. And it will try to reuse a data source configuration that you already have. So you see there in the configuration where it says backing data source name default, that matches this default here, which is the data source name. So in Micronaut you can have multiple data source configurations. So you could have an application that uses multiple databases, and you can select okay, I want to save in this particular data source, and I want to use this table to save it. So I guess this scenario makes sense only when you already are using the database for something else, and instead of creating a new one, you are using just a table of that particular data source. So the scenario that I'm gonna show you today is as follows. So I'm gonna have three environments. I'm gonna have test, I'm gonna have dev. So dev for when I run the application locally, test when I test it, and production. In dev and test, I'm gonna save to disk in my computer, and in production, I'm gonna actually use the S3 storage target to save to a bucket. I'm gonna have three configuration files. I place the application test.properties in the source test resources because I don't need it in the source main resources. And in the source main resources, I have two. I actually have three in the demo that I'm going to show you. I have like application.properties, and then I have one for the other two environments. So I have one application dev properties and application production properties. In the dev environment, I am pointing to a folder in build. Maybe I want to point to a folder in my computer, and that doesn't get removed when I do clean. So that's completely possible. In the test, I am using here another feature of Micronaut, which is you could have like this random sort UID that is at the bottom. I don't really see it from here. Right there, and that will essentially, when the configuration is loaded, it will basically replace that by a random string. So if you want to have in all your tests like a random folder to save, because you are a bit unorganized and you have a lot of test leakage between your tests, this is an option. And for the production configuration, what I showed you before when we were talking about S3, so I have like the bucket name. So one service that I'm gonna use, and it's not required, but I find useful, especially to get started, is AWS Elastic Beanstalk. This has been around for a long time as well, and is what typically they refer to this as a platform as a service. Originally, you could take like a Java application. When we were like deploying WAR files to Tomcat, they will give you like a Tomcat managed for you, and you will like take your WAR and deploy it there. Now they also allow a Java runtime, and they have support, for example, for Java 17, which is what I'm gonna use. And you can take a fat jar that in Micro typically you will generate with Gradle build or maybe in package, and you can take that fat jar and deploy it to Elastic Beanstalk. And what Elastic Beanstalk is going to do is going to create an EC2 machine for you. It's going to put the jar file there, and it's going to run java-jar, and it's going to have integration for all the CPU metrics. It's going to tell you like information about the health of your instance. Allows you to create like a health endpoint where you can configure. I have actually a health endpoint in my application that is using. It's kind of, you forget about how to like essentially set up things, and you just drop your jar file there and they run it for you. So as it says, a single stop application deployment model. There are a couple of things that I want to warn you if you want to try use Elastic Beanstalk. One is, by default, they expect that your application runs in port 5000. Micronaut applications, they start by default in port 8080. Is easily configurable. You can either go to your application properties, application Java, and set micronaut.server.port and whatever port you want, or you can use an environment variable to override that. So what I typically do in Elastic Beanstalk is they have like a panel where you can set like an environment variable, and I set it to server port 5000. Another thing that I do is to set explicitly the Micronaut environments by defining the Micronaut _environment variable, and I do that to essentially control which environment is used when I go to production. Micronaut 3 had a feature called cloud environment detection. When you deploy to a cloud, we will detect in which cloud were you, and we will set that environment. So typically what will happen if you deploy to Oracle Cloud, it will say, okay, environment Oracle Cloud, and even if you were in a function, it will say environment Oracle Cloud and also environment function. And when you deploy to an EC2 machine, it will say, okay, you are environment EC2. Cloud detection is still in Micronaut 4, it still exists, but we have disabled it by default. We have done that because when you run cloud environment detection in your developer machine, you are paying the cost of, even if it's milliseconds, of trying to detect if you are running in EC2, we essentially have disabled that by default. So if you want to use that, you can enable that with an environment variable as well. But my recommendation is in production, just be explicit about which environments you want to use by defining the MicroNTAS environments variable. Another thing that you're going to face in Elastic Beanstalk, not in this scenario, because typically you will not have a load balancer, but I added here because I think it's an easy trap to fall into, is when you deploy in a load balancer, what the load balancer will do is it will essentially hide from you the original IP address, but also even the original host, and it's going to add extra headers to the request that you're going to receive in your Micronaut application, and those extra headers are typically like this: x forwarded for, x forwarded proto, and the host header. We have a feature in Micronaut called host resolution, which you can configure via configuration. So this is typically the configuration that I will use when I go to EC2. I basically add this header so that I know that my host is correctly resolved, and if I want to check, I don't know, like if I want to redirect to another page with an absolute URL, because for example I am composing an email, this will allow me to get actually the correct host. Otherwise you're going to be a bit blind about the real host. If it doesn't suit via configuration, you can always create like a class and replace that. So this is the architecture that I'm gonna try to do. I am working in a pet project called questionnaire training, which is not what we're gonna show you today, but we are gonna use the domain because I already have it set up. And what I want to have is a Micronaut application deployed to an EC2 machine using Elastic Beanstalk and persist to a bucket. In my architecture that I want to do for this pet project, I'm gonna use also another service called Amazon Cognito, which is an identity and access management from Amazon, which will allow me to do Cognito. If you have not used it, it's similar to Auth0 or to Keycloak. It will allow me to, for example, use an Auth2 authorization code grant, which Micronaut security supports, no problem. And I'm going to be able to essentially have my application secured and with users, but I don't have to write any of the code to essentially take care of authentication, registration, password resets, multi-factor authentication, all those things. I don't want to write that. And I'm going to handle that using an authorization service. And in this case, I am using Cognito. Another service from Amazon, which is great, is Amazon Route 53. That's a DNS server. So the way it works is you will typically buy a domain in your registrar. I typically use, for example, one registrar called hoover.com. And you go to the Route 53 console, you register a domain there. No, not register, you create an entry for a domain. And what you are going to do is you're going to go to your domain registrar and you are going to point the records to point to Route 53 so that you are able to do like all the DNS configuration directly in Route 53. And it has a nice feature so that you are able to, for example, put subdomains of your application to certain AWS services, and that's what I'm going to do. I'm going to point the subdomain web app into the application that we're going to deploy to Elastic Beanstalk. And using another service, which is AWS Certificate Manager, which will allow me to get like a certificate for this domain, so that we are going to be able to like access this application. It's going to be hosted in HTTPS, and we are not going to have to basically, if you are going to use AWS, this is, in my opinion, the easiest way to get a certificate, because if you have ever managed certificates, it's a bit of a pain. Certificate managers make it really easy also to connect it to a certain service, and that's what we are going to be using today. So this is going to be the architecture, as simple as this one. I'm not going to show you the Cognito part today because I don't have it in the Eclipse Store demo application that I have. But this is essential when someone visits, actually we're going to visit a subdomain. So when someone visits https://webapp.questionnaire.training, that's going to be handled directly by this EC2 instance, which is deployed to Elastic Beanstalk. And when we save something, it's going to persist in this S3 bucket. So how are we going to deploy? I am gonna use, so for those who have not heard about AWS Code Build, AWS Code Build is the CI service of AWS, so it's the equivalent of Jenkins or a GitHub Actions. So it's a service that we're going to use to build our application and generate an artifact, and then we're going to deploy this artifact to Elastic Beanstalk. And how we are going to coordinate the pipeline, yet another service called AWS Pipeline, which essentially is quite visual. I will show you. It has 3 steps. One is you say, where is the source? I'm going to say the source is in GitHub. I'm going to say the source is in this particular branch, in the main branch. Whenever I push to main, Code Pipeline is going to say, okay, Sergio has pushed to main. Then you define the build step. I'm going to say the build step is going to be in Code Build. Code Build is going to build the artifact. And then you define like a deploy state. And if you deploy to Elastic Beanstalk, it's as easy as saying, okay, I want to deploy to Elastic Beanstalk to this particular application and to this environment. And it's going to do like the 3 steps for us. And hopefully we will be able to see it. So it sounded more complicated than it is. This is essentially our pipeline to deploy. Push to GitHub, build the application in the CI server, which is going to be a Code Build, and deploy to Elastic Beanstalk. How does it look to configure a Code Build to build? If you have worked GitHub Actions and you are enjoying the YAML world, again, this is YAML. Pretty similar. You define the runtime. I am running Java Corretto 17 because I am deploying to Corretto 17 in Elastic Beanstalk. So let me select the same one. I am building with Gradle build that will generate a fat jar. I have some configuration here for Gradle cache so that subsequent builds they reuse some part of the cache. And the other important thing is I am essentially saying that the artifacts of this build is the old jar, which in my case is the fat jar that we want to deploy. So when you run Gradle build in Gradle in a Micronaut application under build libs, you will find like the name of your application, the version.jar, .old-jar. And if you were like building with Maven, it will be in the target directory. And instead of doing Gradle build, you will do like Maven package. But it's the same thing. And this is the pipeline I'm going to show you in a second. And let me show you the demo. For those of you who were not here yesterday, this is not this project, sorry. Let me make it in full screen in presentation mode. Sorry, I don't want to do this. So this is a really simple application. If you attended my talk yesterday, it's the same application. I have a controller, originally named fruits, and it's kind of a CRUD operation. You have like an endpoint to save fruits, which takes like a JSON object. It returns 201 if everything went fine. I have an endpoint to count the number of fruits in the database. I have an endpoint to get a JSON array of the fruits in the database, and I have one to get me like a detail of a particular fruit, which the unique identifier in this case is a name, and an endpoint to delete. I have a couple of pollos that are the ones used by the application. Micronaut supports Java records, so I am not using Java records in this application because this application I originally wrote with Java 17 and compatibility, so that's why I'm not using. But please, if you are using Micronaut with Java 17, enjoy the new features of Java. I have, this is the root graph of my application. So this is the class. If you attended my talk yesterday, we wrote this class yesterday, and this is the actual service where we are doing a persistent with MicroStream. If you didn't attend my talk, in Micronaut we have a set of annotations that allow you to save parts of an object graph, which heavily simplify writing. For example, count is as easy as doing like a size in a list. This is the, I have another nice thing, which maybe you don't know about Micronaut, which is we have open API, sorry, not AI. AI is really, really trendy right now, but open API, which is this standard to document APIs. You can add an annotation processor in your class path called Micronaut Open API. And what we will do is at build time, we will generate the Open API open API specification of your application. So if I do here, let me do clean here. I'm going to do compile Java so that there are no tricks. I'm only compiling. And under so I have a controller I showed you, and I also added my health endpoint. So what this is going to do, and this is pretty spectacular, if you allow me to say so, it's going to generate at build time a YAML file with the documentation of my application, so that if you are collaborating with a team of front-end developers, your contract is an open API specification, and there are no lies here, no thing to maintain. The documentation of your API is generated automatically at build time. We have support for visualizing this documentation. I will show you in a second. I wanted to show you like the dev experience. So I have here a dev data. Since I ran Gradle clean, you see that there is nothing here, so I could run my application here. Probably have like a million things running. Let me kill all minus Java, just in case. So I'm gonna run. This is gonna localhost 8080, I'm gonna do curl local, let me do, I'm gonna save a fruit in my developer, in my dev environment, so I'm gonna save here a banana. So it saved dev data now. This is the data that MicroStream is creating. In the test environment, I have here under test sources, I am using a folder test data because I am actually being a good citizen and cleaning up. So I'm going to run the test, and I think they pass, hopefully. So this is going to save my test data here under test data. I am using the build because it's convenient, because then I can just clean it and it will go away. And in production, I have what I showed you previously in the slide. So I have this configuration that I told you about the host resolution, and then I have a bucket name here, and I have another application in macOS. If you don't know this application, this is an awesome application called Transmit from the people from Panic. I have here like the bucket, so you can basically mount it like if you were using like an FTP application. I'm gonna delete everything so that you trust me that this thing works. I'm gonna empty the bucket, so an empty bucket, right? You see the name. You probably don't see it because the font is tiny, but the name of the bucket matches the name that I have here, right? And the only thing AWS specific that I have in this project, apart from the bucket name, is this file, which is the build-spec.yaml, which defines how to build my application in code pipeline. So I'm gonna log into my AWS console. I should be logged here. And this is code pipeline. And I have this pipeline for questionnaire training. I'm gonna, let's do a change actually. Let's add a controller so that you see that this thing is being deployed and is to be original. I'm gonna do hello world controller. I'm gonna do here controller map string. Micronaut talks JSON by default, so this is gonna deploy. It's going to render this map as JSON. So I can do here collections, singleton map, message, hello world. And I'm going to do the routing hello. And I have to annotate this with at get because this is a get request. And that's all I need to create a route. So I'm going to build here locally just to make sure that the test passed because I'm a good citizen. And we are going to push this to production, and we're going to see the pipeline run. Let me just do that. So I'm going to commit this. I am in the main branch here. So this is going to trigger the pipeline. Hopefully the demo works are with me. I think it said just now it's building the application in the pipeline. And then it will deploy it. And we will know that it deploys because we added a hello world controller. So if we do like a request against hello world, then the application will be there. Configuring this is pretty simple. There is really not much to configure. It is simpler than it sounds. Elastic beanstalk, while this thing deploys, let me show you what I have here. So I have in configuration, I have the environment variables that I showed you in the slides. I am using a tiny machine, which is the T3. Basically, you can tell like two machines. Amazon, if they don't have one, they will give you the other. I think right now it's probably like, let me see which EC2 machine is currently running. It's probably a T3 Micro, which if I remember correctly, T3 Micro, EC2. I think it's half a gig, maybe. T3 Micro is 1 gig of memory. What else do I have? I selected this stick is still building, let me see. Still building, seems. I selected the Java 17 runtime. So in configuration, I have here the Java 17 runtime. I don't have any database or anything like that. I actually have like a load balancer with one instance, a max one instance, because that's the easiest way to get a certificate manager pointing. I have to essentially get rid of the load balancer and point the certificate directly, but that's what I have. I am going to show you the Route 53 configuration that I was mentioning. So I have this service for the DNS called Route 53. You enter here a domain and you can say like, I have here like the web app questionnaire.training. This is the one that it says the record name web app here is pointing to, you say like this is delegating to Elastic Beanstalk. So it's really easy to like route traffic from a subdomain to a particular service. And that's pretty much what we have. So the build successfully is deploying now. The bucket is gonna get quickly some files because we are using a health endpoint. We got already the files from MicroStream. We are using a health endpoint, and in the moment the health endpoint is checked, it's gonna save the MicroStream files that it needs. I'm gonna try to do a curl request. Fruits counts. I have 0 fruits. The application is up. Let me see if this thing it says finished. So in theory we should be able to do like hello, I think we said. So this is just the application that we just deploy. So if I now save a fruit, if I save a fruit in the URL of production, it should be there, and now I am able to query it. So you see it there. Just to show you that this thing is not just in memory, but it's actually being persisted correctly, I could come here and restart the server just for fun. So I'm gonna come here, I'm gonna restart the server, and this is gonna restart the server. So in a second this will be like down. So it's now down, it's been restarted. So the only thing that I did also to go to production with an S3 storage target is here in build.gradle I have these runtime only dependencies that I was showing you before, and I will show you the Swagger annotation in a second because that's cool. And this is the annotation that I was showing yesterday in my demo. So the MicroStream annotation to do the whole persistent. We have this MicroStream REST to be able to visualize in development mode, using the MicroStream GUI to visualize the data. So let's see if we are already up. So you see the application restarted and the data, of course, is there, right? So we are using successfully a storage target of S3. I'm going to show you the last thing, which is not really MicroStream related, but we are not just generating an open API at build time. We are also giving you the Swagger UI to visualize it. So this is the documentation of my API that we generated at build time. That's all I have for the demo, and I think I am also out of time. Are there any questions? Hopefully you saw that it's really easy to go to production with such an architecture. One question there. I have not tried that. I assume it can. I assume, so if I took this data, so I am using transmit, so in theory, I don't know, I could copy this data to my computer and try to access it. I don't know if it does works. I assume it will. I don't see why it will not. But so in theory, I should be able to copy if I. Let me see if I am able to. They have a couple of options to export the data. Even they have an option to export as CSV as well. So that's not really related to the Micronaut integration, but I think they have the option. I have read that in their documentation. So the first question for the video is it possible to download this data that we have in production and access it locally? I think it is. I think I could just download this with this program on my computer and access it. I have not tried it myself, but I don't see why it shouldn't be possible. And the second question is, does MicroStream has an option to export the data? Which is a question that I had also when I was discovering MicroStream, and the answer is yes. And they have, if I remember correctly, they have like a import-export. They have even the option, if I remember, to export as a CSV file. You see here the CSV. Probably don't see it, but there's the option to export to CSV as well. More questions? Please. So you are going to need to have, so the question is, do you have to provide the root, or can I use only the interfaces to store, if I understood correctly? So you are going to have, so a MicroStream supports multiple MicroStream instances. Each instance is going to have a root object, right? So at the end of the day, all your data starts in a root and grows. You have to save. The golden rule of MicroStream is you save whatever you changed. So in my code, for example, I have, so in my code, you can either inject the storage manager, which is the class from MicroStream that's completely supported, and you can use that. Or you can inject the root provider, which is a class that we give you like to get the root. But when you go to save, you save whatever you change. For example, here we are saving this root, which we edited right here, right? So we have an endpoint which is a put request, which changes the description of this thing in the database, and whatever you change in this case is whatever you modified. So in this example is pretty small. The root only have a list, right? But you can imagine that you may have a nested tree, right? And what you will do is whatever part of the tree you retrieve, you modify, that's the only part that you save. So we have like an store root annotation, but you typically shouldn't do that for performance reasons. So you should try to save only the parts of the tree that you changed. Any other questions? No more questions. So thanks a lot, everyone. Hopefully you enjoy the rest of the conference, and yeah, thanks for attending.